Hey champs of Examsnet, welcome to the question series of Examsnet. I hope this series of detailed explanation is helping you a lot. Let's start this session. Here is a question. If delta 1 is equals to 1 PQ, 1 QR, 1 RP and delta 2 is equals to 111 QRP, RPQ, where P is not equal to Q is not equal to R, then delta 1 plus delta 2 is. This type of question basically comes from matrix. Matrix is a combination of rows and columns that we write in a square bracket. Before moving on to the solution of this question, let us understand a basic form. 1AB, 1BC, 1CB is equal to minus of A square plus B square plus C square minus AB minus BC minus CA. Whenever we see any question of this form, then it will always be equal to minus of A square plus B square plus C square minus AB minus BC minus CA. You can see in the question that delta 1 is also of the same form that I have written here. And we will be using this form in this question. We have to find the value of delta 1 plus delta 2. So the value of delta 1 is 1 PQ, 1 QR and 1 RP. And the value of delta 2 is 111 QRP, RPQ. Can you tell me what will be the value of delta 1 by using this form? Yes, you are right. The value of delta 1 will be minus of P square plus Q square plus R square minus PQ minus QR minus RP. Also, there is a rule that if we change the column with row or rows with column, the answers will be equal. In delta 2, you can see that the columns are changed into rows. Means the column of delta 1 are changed into rows in delta 2. Therefore, the value of delta 1 and delta 2 will be equal. So, I can write here 2. Now, further multiplying 2, we get 2p square plus 2q square plus 2r square minus 2pq minus 2qr minus 2rp. Now you can see that here there are 2p square, 2q square and 2r square. So I can write it in this form: p square plus q square minus 2pq plus q square plus r square minus 2qr plus p square plus r square minus 2rp. Now this forms an identity, again this forms an identity and again this forms an identity. So since they are identities, then their answer or solution will be positive. But you can see that before bracket here there is a negative sign. So our final answer will be negative. Next question is, if A minus B into B minus C into C minus A is equal to 2 and ABC is equals to 6, then what is the value of ABC, A square, B square, C square, A cube, B cube, C cube? This question is again from the chapter matrix, and the value which is given in the question is ABC, A square, B square, C square, A cube, B cube, C cube. Now tell me that what is common in this determinant? Yes, ABC is common in this determinant. So in the first step, we are taking ABC common. We get 1 1 1 A B C A square B square and C square. There is a form which you have to remember for solving this question, which is 1 1 1 A B C A square B square C square is equal to A minus B into B minus C into C minus A. You can see here that this part is in the same form. It is a fixed expansion. Whenever we are solving the questions of determinants, we have to remember this expansion. So I am replacing the value of this by A minus B into B minus C into C minus A. So I will get ABC into A minus B, B minus C, C minus A. In the question, the value of ABC is already given, which is 2. And the value of A minus B into B minus C into C minus A is given 6. So therefore, the final answer is 12. Third question is, under which of the following condition does the determinant ABC, BCA, CAB vanish? Here there are 3 conditions and we have to choose the correct condition for this determinant. So firstly, writing this determinant equals to 0. Now we have to apply a expansion in this determinant in column 1. C1 tends to C1 plus C2 plus C3, which means that C1 is equals to C1 plus C2 plus C3. So after applying this expansion, we will get A plus B plus C, B, C, again A plus B plus C, C, A, and again A plus B plus C, A, B. It is equals to 0. Since we have applied the expansion for column 1, so you can see that the changes are in the column 1. Now you can see that A plus B plus C is common in the determinant. So taking A plus B plus C common, we will get 1BC, 1CA and 1AB, which is equals to 0. Again we have a form which we have to remember, which is 1AB, 1BC, 1CB is equals to minus of A square plus B square plus C square minus AB minus BC minus CA. We saw this form in the previous questions. So now I am just replacing the values A plus B plus C, and in the place of this form I am writing the value which is in right hand side into minus of A square plus B square plus C square minus AB minus BC minus CA. It is equals to 0. As you can see here, the determinant was equal to 0. I have replaced the value of this part by this form. So now I get A plus B plus C into minus of A square plus B square plus C square minus AB minus BC minus CA. Both are equals to 0. So there can be 2 conditions. The first condition will be A plus B plus C is equal to 0. And the second condition will be minus of A square plus B square plus C square minus AB minus BC minus CA is equal to 0. Also there can be a third condition, which is when we multiply this A plus B plus C inside of this bracket. So when we multiply this, we get a cube minus of a cube plus b cube plus c cube minus 3abc is equals to 0. So therefore, the statement a plus b plus c is equals to 0, and these two statements are correct for this question. Next question is, consider the following in respect of the matrices. A is equals to mn, b is equals to minus n minus m, and c is equals to m minus m. There are three statements and we have to find that which of the above statements is correct. Again, this is a question from matrix. You can see that matrix is a very important chapter as so many questions come from this chapter. First, let us write all the values that are given in the question, which is a is equals to mn, b is equals to minus n minus m, and c is equals to mn minus m. Let us first see the first statement, which is CA is equals to CB. First, we will solve the left hand side, which is CA. CA will be equals to m minus m into mn. Further multiplying, we get m square mn minus m square minus mn. This is the value of CA. Now let us find the value of CB. CB will be equal to m minus m into minus n minus m. Further multiplying, we get minus mn minus m square, mn and m square. Now you can see that the value of CA and CB is not equal. Therefore, CA is not equals to CB. Option 1 is not correct. Now let us solve the second statement, which is AC is equals to BC. First, finding the value of AC, we get mn into m minus m. Further multiplying, we get m square minus mn. Now finding the value of BC, minus n minus m into m minus m. On further multiplying, we get minus mn and m square. Now we can see that AC is equals to BC. As there is a m square, here also there is a m square. Again there is minus mn, and here also there is minus mn. Therefore, we can say that AC is equals to BC. So option B is correct. Now let us see the option C, which is C into A plus B is equals to CA plus CB. First, solving the left hand side, we get m minus m into mn plus minus n minus m. This is the left hand side, which is C into A plus B. Further solving, we get m minus m into m minus n and n minus m. On further solving, we will get m square minus mn, mn minus m square plus mn and minus mn plus m square. This was the left hand side. Now let us find the value of right hand side. Right hand side is CA plus CB. P. We have already found the values of CA and CB. The value of CA is m square mn and minus m square minus mn, and the value of CB is minus mn minus m square mn and m square. Now adding this both values, we get m square minus mn minus m square plus mn, mn minus m square and minus mn plus m square. This is the value of right hand side. Now you can see that both these values are equal, means LHS is equals to RHS. So we can say that C into A plus B is equal to CA plus CB. In this question, statement 2 and statement 3 is correct. Means the option 2 and option 3 are correct. Next question is, if A is equal to 2 sin theta cos theta 0 minus 2 cos theta sin theta 0 minus 1 1 and 1, then what is A of adjoint A equal to, where I is the identity matrix. This question is also from the matrix, and in this question we have to find the value of A of adjoint A. We know that the value of A of adjoint A is determinant of A into I. Here I is an identity matrix. So in this question we have to find the determinant of A. The value of A is 2 sin theta cos theta 0 minus 2 cos theta sin theta 0 minus 1 1 and 1. In order to find the determinant of a matrix, we have to follow certain steps. Firstly, we have to remove the first row and the first column. After removing the first row and the first column, the remaining terms are sin theta 0, 1 and 1. Then we have to remove the first row and the second column. So when we remove the first row and the second column, the remaining values are minus 2 cos theta, minus 1 and 0 and 1. Again, removing first row and third column. The remaining terms are minus 2 cos theta, minus 1 sin theta and 1. After this step, we have to multiply 3 terms in this brackets, and the 3 terms are of the first row. So the first term will be multiplied with first bracket, the second term will be multiplied with second bracket, and the third term will be multiplied with third bracket. Now it goes like plus, minus, plus, minus. Further solving this, we get 2 sin theta into sin theta minus cos theta into minus 2 cos theta plus 0 into minus 2 cos theta plus sin theta. Further solving, we get 2 sin square theta plus 2 cos square theta, which is equals to 2. Therefore, the right answer is 2. Next question is, for what value of K is the matrix 2 cos 2 theta, 2 cos 2 theta, 6, 1 minus 2 sin square theta, 2 cos square theta minus 1, 3, K, 2K and 1 is singular. We know that when the determinant of any matrix, let us say A, is 0, then it is singular. And the matrix which we have is 2 cos 2 theta, 2 cos 2 theta, 6, 1 minus 2 sin square theta, 2 cos square theta minus 1, 3, and k 2k 1. We have to find that for what value of k will this matrix will be singular. We know that 1 minus 2 sin square theta is equals to cos 2 theta. Also 2 cos square theta minus 1 is equals to cos 2 theta. So replacing the values, we get 2 cos 2 theta, 2 cos 2 theta, 6 cos 2 theta, cos 2 theta, 3, k, 2k and 1. We can see that in the first row 2 is common. So we take 2 common and we get cos 2 theta, cos 2 theta, 3, cos 2 theta, cos 2 theta, 3, and k, 2k and 1. There is a rule that if any two row or column are same, then the value of determinant will be equals to 0. Here you can see that two rows are same. Therefore, the value of this determinant is equals to 0. No matter what the value of k is, since we got two rows common, therefore the value of this determinant is 0. Means for any real value of k, this determinant is singular. So the correct answer is any real value of k. Next question is, let A be a non-singular matrix and B is equals to adjoint of A. Which of the following statements is or are correct? Among these three statements, we have to find that which are the statements that are correct. It is given in the question that A is a non-singular matrix. It means that the value of determinant of A is not equals to 0. And the value of B is given, which is adjoint of A. Let us look at the first statement, which is AB is equals to BA. Putting the value of B here, we get A into adjoint of A is equals to adjoint of A into A. And we know that adjoint of A is equals to determinant of A into I. Therefore, both are equal. So we can say that the statement 1 is correct. Now let us look at the second statement, which is AB is a scalar matrix. In AB, when we replace the value of B, we get A into adjoint of A. And we have already proved that A into adjoint of A is equals to determinant of A into I. Now since it is equals to determinant of A into I, the value of determinant of A will always be scalar. Therefore we can say that AB is a scalar matrix. So option 2 is also correct. Third option is incorrect because it cannot be null. Because we know that the value of determinant A cannot be 0 since it is a non-singular matrix. Therefore, option first and option second is correct. Next question is, consider the following statements in respect of square matrices A and B of same order. First statement is, if AB is a null matrix, then at least one of A and B is a null matrix. It is not a correct statement. The correct statement is, if A is null matrix B is null matrix, or if either of A or B is a null matrix, then AB is also a null matrix. But the reverse of this is not possible. Let us see the reverse of this statement. The reverse of statement is AB is null matrix. So if AB is a null matrix, there are three possible situations. First situation is A will be equals to 0. Second situation will be B will be equals to 0. And the third will be A and B both are not equal to 0. It means that this reverse statement is completely incorrect. Correct statement is if A is null matrix and B is null matrix, or either A or B is a null matrix, then AB will be a null matrix. Its reverse is completely wrong. So the correct statement is statement 2. So the correct answer for this question is 2 only, which is option number B. Next question is, if A is the identity matrix of order 3 and B is its transpose, then what is the value of the determinant of the matrix C is equals to A plus B? It is given that A is an identity matrix and B is its transpose, means B is equal to transpose of A, and we have to find the value of C is equals to A plus B. We know that A is an identity matrix, so A will be equals to I, and also its transpose is equal to I, therefore B is also equals to I. Now putting the values in, C is equals to A plus B, we get C is equals to I plus I, that is equals to 2I. Since it is an identity matrix, we know that 2I is a scalar matrix. It is a scalar matrix, and we know that the determinant of a scalar matrix is equals to A cube. Here the element is A, therefore the determinant of this particular matrix is A cube. We got the value of C is equals to 2I. Therefore, the determinant of C will be equals to 2 cube, which is 8. So the correct answer of this question is 8. Next question is, let A and B be non-singular matrices of the same order such that AB is equals to A and BA is equals to B. Which of the following statements is or are correct? In the question, it is given that A and B both are non-singular matrices, which means that determinant of A is not equals to 0 and determinant of B is also not equals to 0, since it is non-singular. This question came many a times in the exams and it is a very important question. Also given that AB is equals to A and BA is equals to B. In this particular part, AB is equals to A, multiplying A in both the sides, we get ABA is equals to A square. Now replacing the value of BA, which is B, we get AB is equals to A square. Again, replacing the value of AB by A, we get A is equals to A square. Therefore, we can say that the first statement is correct, which is A is equals to A square. Now let us look the second statement, which is AB square is equals to A square B. Again, writing it as A into B is equals to A into B. Now replacing the value of AB in both the sides, we get AB is equals to A into A. Since we know that AB is equals to A, so replacing AB by A, we get AB is equals to A into A. Again, AB is equals to A square. And we know that the value of AB is A and the value of A square is also A. So, we can say that AB square is equal to A square B. Therefore, both the statements first and second are correct. Next question is, how many terms are there in the expansion of 1 plus 2 by x to the power 9 into 1 minus 2 by x to the power 9? This question comes from binomial theorem. Let us see this question. 1 plus 2 by x to the power 9 into 1 minus 2 by x to the power 9. We can write it as 1 plus 2 by x into 1 minus 2 by x whole power 9. Now, further multiplying, we get 1 minus 4 upon x square to the power 9. We know that a plus b whole power 9 have n plus 1 terms. It is also in the form of a plus b to the power n. Therefore, here n is equals to 9 and therefore 1 minus 4 upon x square to the power 9 will have 9 plus 1 terms, which is equals to 10 terms. So, the correct answer is 10. Next question is, consider the following statements in respect of the expansion of x plus y to the power 10. We have an expansion which is x plus y whole power 10. We know that the total terms is equals to n plus 1. Here n is equals to 10. So the total terms is 11 terms. And whenever there are no coefficient in the question, or whenever we see the question in the simplest form like x plus y or a plus b, then middle term is the highest value. So in this question we will find the middle term. Mid term is equals to n plus 1 by 2. N is 11. So 11 plus 1 by 2 gives 6. Therefore first statement is correct, which is among all the coefficients of the terms, the coefficient of the sixth term has the highest value. Therefore we can say that statement 1 is correct. Now let us look at the statement 2, which is coefficient of third term is equal to coefficient of ninth term. Coefficient of third term is represented as T3, which is equal to T2 plus 1, which is equals to 10C2. And the coefficient of ninth term is T9, which is equals to T8 plus 1, which is equals to 10C8. Statement 2 is that the coefficient of third term is equal to the coefficient of ninth term. We know that NCR is equals to NCN minus R. Now let us check it. 10C8 is equals to 10C 10 minus 8, which gives 10C2. Therefore, 10C8 is equals to 10C2, which is that the coefficient of third term is equal to the coefficient of the ninth term. So we can say that both the statements are correct. So the correct answer is both 1 and 2. Next question is, if C 3n comma 2n is equals to C 3n comma 2n minus 7, then what is the value of C n comma n minus 5? It is a question from binomial theorem, and let us first understand a concept before solving this question. NCA is equals to NCB. If we find that NCA is equals to NCB, then there are two possible cases. First case is A is equals to B, and second case is N is equals to A plus B. Now let us see the question. The values are C 3n comma 2n and C 3n comma 2n minus 7, which is equals to 3n C2n and 3n C2n minus 7. Here you can see that the value of A is 3n and the value of B is 2n. Here the value of A is 3n and the value of B is 2n minus 7. So 2n is not equals to 2n minus 7. Therefore A is not equals to B. Means this condition is wrong. So the other condition is true for this question, which is N is equals to A plus B. Here the value of N is 3n, which is equals to A plus B. 2n plus 2n minus 7. Further solving this, we get 3n is equals to 4n minus 7. 4n minus 3n is equals to 7 and n is equals to 7. So we have got the value of n. Now we have to find the value of C of n comma n minus 5. So we can write it as n Cn minus 5. Now putting the value of n here, we get 7C 7 minus 5, which is equals to 7C2. Further solving it, we get 7 into 6 upon 1 into 2, which is equals to 21. Therefore, the correct answer of this question is 21. I hope you understood these questions. Here is a question. What is the value of C 5121 minus C 5122 plus C 5123 minus C 5124 plus C 5125 minus C 5126 plus C 5127 minus C 5128 plus C 5129 minus C 5130. By looking at this question, we think that it is a very complicated question. But no, it is very simple question. This type of question comes from binomial theorem. And before moving on to the solution of this question, let us understand basic concepts. We know that NCR is equals to C of n comma r, and C of n comma r is equals to C of n comma n minus r. Now since this both terms are equal, therefore we can write it as C of n comma r minus C of n comma n minus r is equals to 0. Now let us look at the first term of the question, which is C of 51 and 21. So C of 51 and 21 will be equals to C of 51 comma 51 minus 21, which gives C of 51 comma 30. You can see that C of 51 and 21 is equals to C of 51 and 30. Now in the question, C of 51 and 21 is positive and C of 51 and 30 is negative. Since this both terms are equal, then it will be cancelled out. Similarly, let us look for the other terms. 51 minus 22 is 29. 51 minus 23 is 28. 51 minus 24 is 27. 51 minus 25 is 26. So, like this, all the terms will be cancelled out. We have seen that 51 minus 22 is 29. Therefore, C of 51 and 22 and C of 51 and 29 is cancelled since they are equal. Similarly, 51 minus 23 is 28. Therefore, 51 23 and 51 28 will be cancelled. Similarly, 51 minus 24 is equals to 27. Therefore, 51 24 and 51 27 will be cancelled. And similarly, this both terms will also be cancelled. So, the remaining answer will be 0. Now, we have to look for an option whose answer will be 0. So, let us see the option number C. Option number C is C of 51, 51 minus C of 51, 0. You can see that this is N and this is R. And N minus R is equals to 0, which is written here. So, option number C is correct. Next question is, how many odd numbers between 300 and 400 are there in which none of the digits is repeated? In this question, we have to find the odd numbers between 300 and 400, and we have to keep in mind that the digits should not be repeated. We know that the odd numbers between 300 and 400 will be of 3 digits. So, we have to find 3 digits. We also know that the number from 300 will start with 3. So, the first position will always be 3. Now, tell me that what are the other odd numbers except 3 that comes between 0 to 9. So, the other odd numbers are 1, 5, 7 and 9. So, this will come here. Now, the chances of 3 is 1 as it is a single digit. Chances of this digits is 4 as they are 4 digits. We know that total number of digits from 0 to 9 is 10, and from 10 one digit is used here and one digit is used here. So, the remaining digits are 8. 10 minus 2 is equals to 8. So, now we get the total number of combinations, which is 1 into 8 into 4 gives 32. I hope you have understood this question. It is a very simple question. Firstly, we have taken first position as 3 because we know that first position is always 3. And other than 3, the odd numbers are 1, 5, 7, 9. Now here, why I have not written 3? Because we cannot repeat any digits. Therefore, I have not written 3 here. So, the chances of 3 is 1 and the chances of this numbers is 4. And from 10, 2 digits are already used. So, the remaining digits are 8. In this way, we get the answer 32. Next question is, how many permutations are there of the letters of the word tiger in which the vowels should not occupy the even positions? This type of question comes from permutations and combination. In this question, we are asked to find permutations of the letters of the word tiger in which vowels should not occupy the even positions. So, the word tiger contains 2 vowels. So, can you tell me what are the 2 vowels? Yes, 2 vowels are I and E. And we know that the vowels should not come on the even positions. Total number of positions is 5. And out of 5, these 3 positions are odd. So, from these 3 positions, we need to fix 2 positions for vowels. So, out of 3 positions, we pick 2 positions for vowels, which will be equal to 3p2. Now, out of 5, we have fixed 2 positions. So, the remaining positions are 3. So, these 3 positions are for consonants. So, the chances of filling the consonants is 3 factorial. Now, let us solve this further. 3p2 is equals to 6 and factorial 3 is also equal to 6. So, the possible permutations are 36. Next question is, let alpha and beta be the roots of the equation x square plus px plus q is equals to 0. If alpha cube and beta cube are the roots of the equation x square plus mx plus 9 is equals to 0, then what is the value of m plus n? It is given in question that alpha and beta are roots of the equation. Therefore, we can find the value of alpha plus beta and alpha into beta. We know that alpha plus beta is equals to coefficient of x. So, minus of coefficient of x will be minus p. And alpha into beta is equals to c. So, in the equation c is equals to q. Therefore, alpha plus beta is equals to minus p and alpha into beta is equals to q. I hope you are getting it. This type of question comes from the quadratic equation. Now, in the second part of the question, it is given that alpha cube and beta cube are the roots of the equation x square plus mx plus 9. So, from here we can find the value of alpha cube plus beta cube, which will be equal to minus of coefficient of x. So, you can see that here the coefficient of x is m. So, alpha cube plus beta cube is equals to minus m. Similarly, we can find the value of alpha cube into beta cube, which is equals to c, and the value of c here is n. So, in this way, we have got this values and we have to find m plus n. You can see we have already got the value of n, which is alpha cube into beta cube, and the value of m will be minus of alpha cube plus beta cube. So, m plus n will be equals to minus of alpha cube plus beta cube plus the value of n is alpha cube into beta cube. Now there is a formula which is alpha cube plus beta cube is equals to alpha plus beta whole cube minus 3 alpha beta and alpha plus beta. Now putting the value of the formula here, we get m plus n is equals to minus of alpha plus beta whole cube minus 3 alpha beta into alpha plus beta. And the second term was plus alpha cube into beta cube. So I can write it as alpha into beta whole cube. Now putting the values of alpha and beta, we know that alpha plus beta is minus of p. So therefore minus of minus p cube minus 3. The value of alpha into beta is q. We have already found the values. And the value of alpha plus beta is again minus p. Again the value of alpha into beta is q. Therefore q cube. Further solving this question, we get p cube minus 3p cube plus q cube, which is equals to p cube plus q cube minus 3p cube. So this is the correct answer. Next question is, let alpha and beta be the roots of the equation x square minus ax plus bx plus ab minus c is equals to 0. What is the quadratic equation whose roots are a and b? You can see that this question is also from the quadratic equation. Now we know that alpha and beta are the roots of the given equation. So we can find the value of alpha plus beta and alpha into beta. So here alpha plus beta is coefficients of x. Coefficients of x are a plus b. And alpha into beta is the value of c. The value of c is ab minus c. So alpha into beta will be ab minus c. It is asked that which of the following quadratic equation is correct whose roots are a and b. We know that there is a quadratic equation whose roots are a and b. And the quadratic equation is x square minus a plus b into x plus ab. This is the equation whose roots are a and b. So in this equation, when we put the values, we get x square minus a plus b is equals to alpha plus beta. We have already found here. and A into B is alpha plus beta plus C. From here we will find the value of AB, which is alpha beta plus C. Further solving, we get x square minus alpha x minus beta x plus alpha beta plus C is equals to 0. So this is the correct quadratic equation. Next question is, if the roots of the equation x square minus ax minus bx minus cx plus bc plus ca is equals to 0 are equal, then which of the following is correct? Given that the roots of this equation is equal, and we know that when the roots are equal, only if d is equals to 0. And what is d? D is b square minus 4ac. Means when b square minus 4ac will be 0, then the roots of any equation is equal. And it is already given in the question that roots are equal. Therefore, b square minus 4ac is equals to 0. We know that b square is the coefficient of x. So putting the value here, b square will be a plus b plus c square. You can see in the equation that the coefficient of x is a, b and c. Therefore, the value of b will be a plus b plus c minus 4 into ac. Now, what is the value of ac here? The value of a is 1 and the value of c is bc plus ca. You can again see in the equation the value of a is 1 and the value of c is bc plus ca. We are comparing it with the equation ax square plus bx plus c. So the value of b is, we know, coefficient of x. The value of a is coefficient of x square. Here the coefficient of x square is 1. Therefore the value of a is 1. And remaining is the value of c, which is bc plus ca. Now this is equals to 0. Further solving it, we get a square plus b square plus c square minus 2ab plus 2bc plus 2ca. Here there will be also plus. Minus 4bc minus 4ca. Now you can see that this particular term is also equals to 0 and the second term is also equals to 0. Now the first term makes a formula which is a plus b minus c square is equals to 0. From this first term we get a formula which is a plus b minus c whole square is equals to 0. Therefore the correct option is a plus b minus c is equals to 0. Next question is, let alpha and beta be the roots of the equation x square minus 8r plus q is equals to 0. If alpha square minus beta square minus 16, then what is the value of q? See, here is a slight mistake in the question. The value of alpha square minus beta square is equal to 16, not minus 16. So we know that when the roots are given, we can find the value of alpha plus beta and alpha into beta. So alpha plus beta will be equal to coefficient of r here. So the coefficient of r is 8 and alpha into beta will be the value of c, which is q. Given that alpha square minus beta square is equals to 16, it is already given in the question and we have to find the value of q. Further solving this, we get alpha plus beta into alpha minus beta is equals to 16. So the value of alpha minus beta will be 16 upon alpha plus beta, which is equals to 16 upon 8. The value of alpha plus beta is 8. So the value of alpha minus beta is 2. Now we have the value of alpha minus beta is 2 and alpha plus beta is 8. After this we have to find two digits whose difference is 2 and whose whose sum is 8. So the two digits are 5 and 3. We can see that 5 minus 3 is equals to 2 and 5 plus 3 is equals to 8. So the two numbers are 5 and 3. So I can say that alpha is equals to 5 and beta is equals to 3. In order to find the value of q, we will use alpha into beta is equals to q. We have already found out. So putting the values here, 5 into 3 is equals to q means the value of q is 15. So in this way we find the value of q. Next question is, what is the maximum value of n such that 5 power n divides 30 factorial plus 35 factorial, where n is a natural number. We have to find that what value of n such that 5n divides 30 factorial plus 35 factorial. Factorial is 30 factorial plus 35 factorial. Now taking common 30 factorial from this, we get 1 plus what is remaining? 31 into 32 into 33 into 34 into 35. When we multiply all these terms, then the unit digit will be 0. Why? Because 5 into 2 is 10 and the unit digit will be 0. And we know that if the unit digit is 0 and we add 1 in it, then the whole answer will be having a digit whose unit digit will be 1. See, when we multiply all these terms, the unit digit is 0. And if any unit digit is 0 and we add 1 to it, then the whole answer will be 1. Means the unit digit of this full term will be 1. See, it is very simple. If the unit digit of this term is 0 and we add 1 in it, then the whole unit digit will be 1. And we know that if the unit digit is 1, then it cannot be divided by 5. So 30 factorial will only be divided by 5. Have you understood this concept? It was a very basic concept. When one digit contains a unit digit 0 and we add 1 to it, then the unit digit of the whole number becomes 1. And we know that when unit digit is 1, it cannot be divided further by 5. So what is remaining? The remaining term is here 30 factorial. So 30 factorial will be divided by 5. Now we will use greater integer factor. So we use greater integer factor in this way, 30 upon 5 plus 30 upon 5 square. Okay, so here we do not need to take the full term. We will just take the term which is directly divisible by 5. So it will be equal to 6 plus 1, which is equals to 7. So the final answer is 7. Next question is, what is the value of 2 into 2 into 1 plus 3 into 3 into 2 into 1 plus 4 into 4 into 3 into 2 into 1 plus so on. Now you can see one thing in this question, that this question is in the form 2 into 2 factorial plus 3 into 3 factorial plus 4 into 4 factorial plus so on. Okay, so there is a formula which is a into a factorial plus a plus 1 into a plus 1 factorial plus so on b into b factorial. So it is always equals to b plus 1 factorial minus a factorial. You can see that the question is in this form. Here a is 2 and again 2 factorial. Then a plus 1 is 3. Then 3 into 3 factorial. Then it is moving on up to 9 factorial. And at last there is plus 2. So when we use this formula, then we get, see here b is what? The total numbers, means up to where the series is going. So our series is going up to 9. So the value of b is 9. So factorial of 9 plus 1 minus the value of a. A means the starting term. Starting term in the question is 2. Therefore minus factorial 2. And you can see in the question plus 2 is also there at the last. So writing here plus 2. So 10 factorial minus 2 factorial plus 2. Now minus 2 factorial and 2 is equal because 2 factorial is also equal to 2 into 1. So the answer is 10 factorial. Next question is, if A is equals to 1, 2, 3, then how many elements are there in the power set of A? It is given that A is equals to 1, 2, 3. And we know that elements in the power set is 2 to the power n. Now tell me how many elements are there in A? In A, there is only one element, which is 1, 2, 3. See, this is a single element. Most of the students do mistake here. They think that there are 3 elements, but no. This is a single element which is 1, 2, 3. Therefore, n is 1. Therefore, 2 power 1 is 2. Now you are thinking that what are the 2 elements? So, the 2 elements will be, one is 5 and one is 1, 2 and 3. So, these are the 2 elements in the power set of A. I hope you have understood all these questions properly. Here is a question. If A, B and C are in GP, where A, B and C are greater than 0, then which of the following statements are correct? Since it is given that A, B and C are in GP, then we can write it as B square is equals to AC. Because we know that if any terms are in GP, then B square is always equals to AC. This type of question basically comes from sequence and series. So now let us move on to the solution of this question. For checking the first statement here, we will square on both the sides. So after squaring on both the sides, we will get B square whole square is equals to A square C square. Now you can say that the first statement is correct because as I told you that A, B and C are in GP, therefore B square is equals to AC. And now A square, B square and C square are in GP. Then B square whole square is equals to A square, C square. So first statement is correct. Now for the second statement, doing the reciprocal of B square is equals to AC, we get 1 upon B square is equals to 1 upon A into 1 upon C. Now further I can write it as 1 upon B square whole square is equals to 1 upon A into 1 upon C. Here also B square is equals to AC. It means that it is in the same form, which is B square is equals to AC. Therefore option 2 is also correct. Now let us look at the third option. Third option is root A, root B and root C are in GP. So in order to get the terms in root, we have to put root in B square is equals to AC. Therefore, root of B square is equals to root of A into root of C. I can write it as root of B whole square is equals to root A into root C. Again, this is in the same form, which is B square is equals to AC. Therefore, option 3 is also correct. So, we can say that all the 3 options are correct. Next question is, if A plus B by 2, B and B plus C by 2 are in HP, then which of the following is correct? Again, you can see that this is the question from sequence and series. It is given in the question that A plus B by 2, B and B plus C by 2 are in HP. It means that it reverse will be in AP. So what is the reverse of it? 2 by A plus B, 1 by B and 2 by B plus C. These are the terms which are in AP. We can also write it as 2 by b is equals to 2 by a plus b plus 2 by b plus c. It is a very simple step. Now, if we take the LCM of this step, then 2 will be removed because 2 is common. As you can see that 2 is common in both the sides. Therefore, the remaining terms will be 1 by b is equals to a plus 2b plus c upon ab plus ac plus b square plus bc. Now again, cross multiplying the terms, we get AB plus AC plus B square plus BC is equals to AB plus 2B square plus BC. You can see that here also there is a BC and here also there is a BC. So BC and BC will be cancelled. Again, AB and AB also will be cancelled. So the remaining terms are 2b square minus b square is equals to AC. Therefore, b square is equals to AC. See, this is the term that we also looked in the previous question. And if we get this term, then we can say that the elements are in GP. Therefore, we can say that A, B and C are in GP. So, this is the correct option for this question. Next question is, what is the value of cot square 15 and tan square 15? This is a question from trigonometry, which is very useful in mathematical applications. So now let us see this question. Cot square 15 plus tan square 15. We can write tan 15 as tan 45 minus 30. We know the formula of tan A minus B, which is tan A plus tan A minus tan B and 1 plus tan A tan B. So here I am applying the formula of tan A minus B, which is tan A minus tan B upon 1 plus tan A into tan B. I hope it is clear up to this step. We have just applied the formula for a tan A minus B. Now keeping the values, tan 45 is 1, tan 30 is 1 upon root 3. Again 1 plus 1 upon root 3, which becomes root 3 minus 1 upon root 3 plus 1. Now rationalizing this term, root 3 minus 1 upon root 3 plus 1 into root 3 minus 1 upon root 3 minus 1. We get 3 minus root 3 plus 1 upon 3 minus root 3 plus root 3 minus 1, which is equals to 4 minus 2 root 3 upon 2. This plus root 3 and minus root 3 will be cancelled. Now taking 2 common from this, 2 minus root 3 upon 2. So the remaining answer is 2 minus root 3. Now we have got the value of tan 15, which is 2 minus root 3. Now let us look at the another term, which is cot 15. I can write cot 15 as 1 upon tan 15. And we already know the value of tan 15, which is 1 upon 2 minus root 3. Again rationalizing this term, we get 2 plus root 3 upon 4 plus 2 root 3 minus 2 root 3 minus 3, which is equals to 2 plus root 3. So now we have got the value of cot 15, which is 2 plus root 3. Here you can see that the value of tan 15 is 2 minus root 3, and now we have found out the value of cot 15, which is 2 plus root 3. In this question, we have to find the value of cot square 15 plus tan square 15. We know the value of cot 15, which is 2 plus root 3. Since here there is a cot square 15, so I am putting a square here. And we know the value of tan 15. The value of tan 15 is 2 minus root 3. We have already found it. Again I am putting a square. Now just simplifying it, we get 4 plus 3 minus 4 root 3 plus 4 plus 3 minus 4 root 3. So the answer will be 14 for this question. Here I have just applied a plus b whole square formula. So 2 square is 4, root 3 square is 3, and 2ab means 2 into 2 into root 3 will be plus 4 root 3. Again, in this also I have applied the formula of a minus b whole square, and I have got these 3 terms, and after simplifying it we get 14. So 14 is the answer for this question. Next question is, in a triangle ABC, sin A minus cos B minus cos C is equals to 0. What is angle B equal to? Again this question is from trigonometry. It is given that sin A minus cos B minus cos C is equals to 0. So let us write it first. Sin A minus cos B minus cos C is equals to 0. Now I can write it as sin A minus cos B plus cos C is equals to 0. What we have done in this step is we have taken the minus common from cos B and cos C. Now further putting the formula of half angle, we get 2 sin A by 2 cos A by 2 minus 2 cos B plus C by 2 into cos B minus C by 2 is equals to 0. I hope it is clear. We have just kept the formula of half angle and we got this term. Now we know that sum of angles of triangle is equals to 180 degree. So we can write A plus B plus C is equals to pi. Pi is 180 degree. And B plus C will be equals to pi minus A. Now dividing 2 on both the sides, we get B plus C by 2 is equals to pi by 2 minus A by 2. Now, if we put sign on both the sides, we get sin B plus C by 2 is equals to sin pi by 2 minus A by 2. And we know that sin pi by 2 minus A by 2 is equals to cos pi by 2. So we can say that the value of sin B plus C by 2 is cos pi by 2. Similarly, cos B plus C by 2 will be equal to sin pi by 2. Sorry, here there is A, sin A by 2. We know that sin 90 minus theta is cos theta. So sin pi by 2 minus A by 2 will be cos A by 2. See, now we have just solved a formula, means we have derived a formula which is sin 90 minus theta is equals to cos theta. But you just have to remember this part, that sin B plus C by 2 is equal to cos A by 2, and cos b plus c by 2 is equals to sin a by 2. So now we will have to replace the values. So our last step was 2 sin a by 2 cos a by 2 minus 2 cos b plus c by 2 cos b minus c by 2 is equals to 0. Now replacing the value of cos b plus c by 2, which is equals to sin a by 2. So here in this place I will be writing sin a by 2, which we have already found here. So the next step will be 2 sin a by 2 cos a by 2 minus 2 sin a by 2 cos b minus c by 2 is equals to 0. Now you can see here 2 sin a by 2 and 2 sin a by 2 is common. So now taking common in the next step, we get 2 sin a by 2 and then the remaining terms, which is cos a by 2 minus cos b minus c by 2 is equals to 0. Now there are two parts, and in this either this part will be equals to 0 or this part will be equals to 0. You can see that there are two parts. Now talking about 2 sin a by 2, 2 sin a by 2 cannot be equal to 0, because if 2 sin a by 2 is 0, then a will be also 0. And if a is 0, then one angle of triangle will be 0, means no triangle will be formed. But in question it is given that a triangle is formed. So a cannot be 0. Therefore, this whole term cos a by 2 minus cos b minus c by 2 will be equal to 0. So cos a by 2 minus cos b minus c by 2 is equals to 0. Now further solving it, cos a by 2 is equals to cos b minus c by 2. Now cos and cos will be cancelled. So a by 2 is equals to b minus c by 2. Again 2 and 2 will be cancelled. So a is equals to b minus c. Or a plus c is equals to b. So we have got the value of b, which is a plus c. Now we know that sum of angles of a triangle is 180 degree. So a plus b plus c is 180 degree. Now I can write it as a plus c plus b. It doesn't matter. So we know a plus c is b. Again plus b is equals to 180 degree. 2b is equals to 180 degree. Therefore b will be equals to 90 degree. Or we can say that b is equals to pi by 2. As we know that 180 degree is equals to pi. So 90 degree will be is equals to pi by 2. So the value of b is pi by 2. Next question is, if alpha plus beta is equals to pi by 4 and 2 tan alpha is equals to 1, then what is tan 2 beta equal to? Again you can see that this is a question which comes from the most important topic, which is trigonometry. And you also have to understand that it is very useful in mathematical applications. So now in question it is given that alpha plus beta is equals to pi by 4. Also 2 tan alpha is equals to 1. It means that tan alpha is equals to 1 by 2. Clear? Now putting tan alpha on both the sides of this part, we get tan alpha plus beta is equals to 10 pi by 4. What we have done is we have put 10 on both the sides. So now we'll apply the formula of tan a plus b. which is 10a plus 10b upon 1 minus 10a 10b. Here a is alpha and b is beta. Now it is equals to 10 pi by 4. The value of 10 pi by 4 is 1. Further solving it, we get 10 alpha plus 10 beta is equals to 1 into 1 minus 10 alpha 10 beta. This term will go there, so it will become like this. Now we know the value of 10 alpha, which we have already found, which is 1 by 2. So I will keep the value of 10 alpha here. So 1 by 2 plus 10 beta is equals to 1 minus 1 by 2 10 beta. Now 10 beta plus half 10 beta is equals to 1 minus 1 by 2. What I have done is I have taken the terms which have 10 beta on one side and the numbers on other side. So further solving it, we get 3 by 2 10 beta is equals to 1 by 2. 10 beta is equals to 1 by 3. Now we have found out the value of 10 beta, but in question we have to find the value of 10 2 beta. So now let us see it. 10 2 beta is equals to 2 10 beta upon 1 minus 10 square beta. We know the formula 10 2 theta is equals to 2 10 theta upon 1 minus 10 square theta. In place of theta, here there is beta. So now further, when we keep the values, we get 2 into 1 by 3 upon 1 minus 1 by 9. Further, when we solve it, we get 2 by 3 upon 8 by 9. So when we cancel it out, we get the answer as 3 by 4. You already know that whenever we get this form, then it is always equals to a by b into d by c. So in this way we get the answer 3 by 4. Next question is, if tan 45 plus theta is equals to 1 plus sine 2 theta, where theta lies between minus pi by 4 and plus pi by 4, then what is the value of cos 2 theta? It is given in the question that theta lies between minus pi by 4 and plus pi by 4. So we can easily say that 2 theta will lie between minus of pi by 2 and plus of pi by 2. Now we have the values on the left hand side, which is tan 45 plus theta. Tan 45 plus theta. Here we will keep the formula for tan a plus b. Then we will get tan 45 plus tan theta upon 1 minus tan 45 tan theta. Now we know that the value of sine 2 theta is equals to 2 tan theta upon 1 plus tan square theta. Therefore, putting the value of sine 2 theta in the right hand side, you can see that the right hand side is 1 plus sine 2 theta. So here I will keep the value of sine 2 theta. So in the left hand side, we have already solved the formula for tan a plus b, and we got tan 45 plus tan theta upon 1 minus tan 45 tan theta. Now I am keeping 1 plus sine 2 theta. So sine 2 theta is equals to 2 tan theta upon 1 plus tan square theta. Further solving it, we get tan 45 is 1 plus tan theta and 1 minus tan theta, because tan 45 is 1. So it will be 1 plus tan theta and 1 minus tan theta. And in the right hand side, it will be 1 plus tan squared theta by 1 plus tan square theta. Here there will be the whole square because it will be multiplied with here also. So have you understood this step? It is quite easy. Tan 45 is 1 and again here tan 45 is 1. So in the left hand side we get 1 plus tan theta and 1 minus tan theta. In the right hand side we have just cross multiplied. Then we got 1 plus tan theta whole square and upon 1 plus tan square theta. Now you can see that here there is 1 plus tan theta on the left hand side and here there is 1 plus tan theta whole square. So I can cancel one term easily. So I will have 1 upon 1 minus tan theta is equals to 1 plus tan theta upon 1 plus tan square theta. Again cross multiplying, we get 1 plus tan square theta is equals to 1 minus tan square theta. Now taking both on one side, we get 1 minus tan square theta upon 1 plus tan square theta. We know that cos 2 theta is equals to 1 minus tan square theta upon 1 plus tan square theta. So in place of this whole term, I can put cos 2 theta. So 1 is equals to cos 2 theta. Therefore, cos 2 theta is equals to 1. So we have found the value of cos 2 theta in this way. So students, you can see that there are so many questions of trigonometry, and whenever a question comes from the trigonometry part, you just have to work on the formulas. Means you have to revise and learn more and more formulas. So it will make it quite easier for you to solve any kind of questions. Next question is, let sine 2 theta is equals to cos 3 theta, where theta is an acute angle. What is the value of 1 plus 4 sine theta? And also given that sine 18 is equals to root 5 minus 1 upon 4. So now let us solve this question. But before that, let us understand a concept, which is if cos A is equals to sine B, then A plus B is equals to 90 degree. It is a very basic concept from the trigonometry part. So here we have sine 2 theta is equals to cos 3 theta. We can write it as sine 2 theta is equals to sine 90 minus theta. Further solving, this sine and sine will be cancelled. So remaining will be 2 theta is equals to 90 minus 3 theta. 5 theta is equals to 90 and theta is equals to 90 upon 5, which is 18 degree. Now we have to find 1 plus 4 sine theta. We already got the value of theta, which is 18. So we will keep here 1 plus 4 sine 18 degree. And in the question, see that the value of sine 18 degree is given. So we will put this value. 1 plus 4 and the value of sine 18 is root 5 minus 1 upon 4. So this 4 and 4 will be cancelled. So remaining will be 1 plus root 5 minus 1. So the final answer is root 5. See, some questions of trigonometry are very simple. You just have to think about it and then use the right formula and then get the right answer. Next question is, if tan theta is equals to minus 5 by 12, then what can be the value of sine theta? You can see that tan theta is negative here. And we know that tan theta is negative in second and third quadrant. And we also know that tan theta is equals to perpendicular upon base. Okay. So first let us see. This is base, which is 12. This is perpendicular. And if perpendicular is 5 and base is 12, then the hypotenuse will be 13. So the value of tan theta is given minus 5 upon 12, which is perpendicular upon base. And generally sine theta is perpendicular upon hypotenuse, which is equals to 5 upon 13. But if tan theta is in second quadrant, then value of sine theta will be positive, which is plus 5 upon 13. Because sine theta is always positive in second quadrant. Also, if the value of tan theta is in third quadrant, then sine theta will be negative. So in that case, we will get the value of sine theta as minus 5 by 13. Have you understood the concept? See, I told you that tan theta here is negative. It is given in question. And we know that tan theta is negative in second and third quadrant. So there are two possibilities. If tan theta is in second quadrant, then the value of sine theta will be positive, which is 5 by 13. And if tan theta is in second quadrant, then sine theta will be positive, as I told you. And again, if tan theta is in third quadrant, then sine theta will be negative, which is minus 5 by 13. So there are two possibilities of answers. So the correct answer will be 5 by 13 or minus 5 by 13. Okay, because we don't know that in which quadrant tan theta lies. In question only the value is given, quadrant is not given. So it is a very basic concept that if tan theta is in second quadrant, then the value is positive. And if tan theta is in third quadrant, then the value of sine theta will be negative. So either we can get this value or we can get this value. So the correct answer is 5 by 13 or minus 5 by 13. Next question is, what is the value of cos power 4 7 pi by 8 plus cos power 4 5 pi by 8? Again, this is a question from trigonometry. And before solving this question, let us first understand a very important formula. Cos 2 theta is equals to 2 cos square theta minus 1. From here, we can get the value of cos square theta, which will be 1 plus cos 2 theta upon 2. Now let us come to the question, which is cos power 4 7 pi by 8 plus cos power 4 5 pi by 8. See, this is a very important formula of trigonometry, and I have seen that all the students forget this formula. So it is very important to remember this formula. Now, before moving on to the question, we can write it as cos square 7 pi by 8 whole square plus cos square 5 pi by 8 whole square. Now, applying the formula, we get 1 plus cos 7 pi by 4 by 2 whole square plus 1 plus cos 5 pi by 4 upon 2 whole square. Have you understood this step? I have applied the formula for cos square theta, which we have already found here. So cos square theta is equals to 1 plus cos 2 theta upon 2. So here we have cos square theta means cos square 7 pi by 8, which is equals to 1 plus cos 2 theta upon 2. So 1 plus cos theta upon 2 whole square. Instead of writing 2 theta, I have kept here square. Similarly, for cos square 5 pi by 8, it will be 1 plus cos 5 pi by 4 upon 2. Now you can see that both the terms have 2 in denominator. So we can take 1 by 4 common. Also, 7 pi by 4 can be written as 2 pi minus pi by 4, because when we solve 2 pi minus pi by 4, we will get 7 pi by 4. Now, if we put cos on both the sides, we get cos 7 pi by 4 is equals to cos 2 pi minus pi by 4. Now again there is a formula which is cos 2 pi minus theta is equals to cos theta. The cos theta will be positive in fourth quadrant. So we can say that cos 7 pi by 4 is equals to cos pi by 4 by using this formula. Here there is cos 2 pi minus theta, which is equals to cos theta. So now I have got the value of cos 7 pi by 4, which is cos pi by 4. Now another term was 5 pi by 4. It can be written as pi plus pi by 4. Again, putting cos on both sides, we get cos 5 pi by 4 is equals to cos pi plus pi by 4. Now we know that cos pi plus theta is equals to minus cos theta. So cos pi plus pi by 4 is equals to minus cos pi by 4. Therefore, we can say that cos is negative in third quadrant. So the value of cos 5 pi by 4 is minus of cos pi by 4. Now the last step was this step. So from this step, if I take 1 by 4 common, then we will get 1 by 4, 1 plus cos 7 pi by 4 whole square plus 1 plus cos 5 pi by 4 whole square. Now we have found out the value for cos 5 pi by 4, which is minus cos pi by 4, and the value of 7 pi by 4 is cos pi by 4. So putting the values here, we get 1 by 4, 1 plus cos pi by 4 whole square plus 1 minus cos pi by 4 whole square. We have just put the value of 7 pi by 4 and 5 pi by 4. Now further solving it by the formula a plus b whole square, we will get 1 by 4, 1 plus cos square pi by 4 plus 2 cos pi by 4 plus solving for 1 minus cos pi by 4 whole square means a minus b whole square, we will get 1 plus cos square pi by 4 minus 2 cos pi by 4. Now you can see that here there is plus 2 cos pi by 4 and here there is minus 2 cos pi by 4. So this both terms will be cancelled. Now the remaining terms will be 1 by 4 into 2 plus 2 cos square pi by 4. Further solving it, we get 1 by 4 into 2 plus 2 into 1 by root 2 whole square. Because we know that the value of cos pi by 4 is 1 by root 2. So cos square pi by 4 will be 1 by root 2 whole square. Further solving, we get 2 plus 2 into 1 by 2. So 1 by 4 into 2 plus 1, which is equals to 3 by 4. So 3 by 4 is the correct answer for this question. I hope it is clear to you. Next question is, what is sine square pi by 4 plus theta minus sine square pi by 4 minus theta equal to? See, you can see that trigonometry covers a huge portion of question in this exam. So prepare well for the trigonometry part. The question is sine square pi by 4 plus theta minus sine square pi by 4 minus theta. We know a formula which is sine square A minus sine square B is equals to sine A plus B into sine A minus B. You can see that the question is in the same form, sine square A minus sine square B. So further putting this formula, we get sine A plus B means pi by 4 plus theta plus pi by 4 minus theta. The value of A is pi by 4 plus theta and the value of B is pi by 4 minus theta into sine A minus B. Sine A minus B will be pi by 4 plus theta minus pi by 4 plus theta. Further solving it, we get sine 2 pi by 4 into sine 2 theta. Now sine 2 pi by 4 will be equals to sine pi by 2 into sine 2 theta. We know the value of sine pi by 2. Sine pi by 2 is 1. Therefore 1 into sine 2 theta is equals to sine 2 theta. So this is the correct answer for this question. Next question is, a vertical tower stands on a horizontal plane and is surrounded by a vertical flagstaff of height h. At a point on the plane, the angles of the elevation of bottom and top of the flagstaff are theta and 2 theta. What is the height of the tower? See, this type of question comes from the applications of trigonometry. You are very well familiar with trigonometry. Now we have to focus on the applications of trigonometry. So first, let us make the diagram for this question. The question says a vertical tower stands on a horizontal plane. So this is a horizontal plane and a vertical tower stands on it. And it is surmounted by a vertical flagstaff. Now it is surmounted means top of that there is a flagstaff whose height is h. So the height of this part is h. Okay. At a point on the plane of angles of elevation means on the horizontal plane we can take any point. So I have taken the point here. The elevation of bottom and top of the flagstaff are theta and 2 theta. Okay, so let us first draw two lines. This is the bottom line and this is the top line. So the angles are theta and 2 theta. So this angle will be theta and this whole angle will be 2 theta. Is it clear? Now we have to find what is the height of the tower. See, we know that the height of the tower is from here to here. So we have to find the height of the tower. And this particular portion will be x. So I hope you have understood the diagram. It is very easy to make a diagram of this question. Now moving further, we know that tan theta is equals to perpendicular upon base. So for the tower, the perpendicular is h and base is x. So I can write h upon x. Again, tan 2 theta means the whole triangle. Let us give names to this: A, B, C and D. So for triangle ABC, tan theta is equals to h upon x. Now for triangle ABD, tan 2 theta will be perpendicular is this whole thing, means h plus h upon x. Now you can see that in both the terms denominator have x. So from first term we will write it as tan theta is equals to h upon x, and from here we will find the value of x, which will be h upon tan theta. Now putting the value of x in the second term, which is here, we have to put the value in tan 2 theta. So we know that tan 2 theta is equals to h plus h upon x. So here when I keep the value of x, I get h plus h upon tan theta, which will be equal to h plus h into tan theta upon h. Now we know the formula for tan 2 theta. In the left hand side there is tan 2 theta. So putting the formula for tan 2 theta, we get 2 tan theta upon 1 minus tan square theta, and right hand side is equals to h plus h into tan theta upon h. Now you can see that in the left hand side there is 2 tan theta, and in the left hand side there is 1 tan theta. So 1 tan theta will be cancelled. So here the remaining terms will be 2 upon 1 minus tan square theta is equals to h plus h upon h. Further cross multiplying, we will get 2h is equals to h plus h into 1 minus tan square theta. Now further solving, we get 2h is equals to h minus h tan square theta plus h minus h tan square theta. Again, next step will be 2h minus h plus h tan square theta is equals to h minus h tan square theta. What we have done is we have taken the capital H on one side and the small h on other side. So h plus h tan square theta is equals to h minus h tan square theta. Now we can take common h. So when I take common, I will get h, then in bracket 1 plus tan square theta is equals to h 1 minus tan square theta. Now I have to find the value for capital H. Capital H is the height of the tower. So capital H is equals to h into 1 minus tan square theta upon 1 plus tan square theta. See, now again you can see a formula in this step, which is 1 minus tan square theta upon 1 plus tan square theta. This is equals to cos 2 theta. Therefore h is equals to h into cos 2 theta. Because cos 2 theta is equals to 1 minus tan square theta upon 1 plus tan square theta. So the value of height of the tower is h cos 2 theta. Now let us see the next question, which is the shadow of a tower becomes x meter longer when the angle of elevation of sun changes from 60 degree to theta. If the height of the tower is root 3x meter, then which of the following is correct? Now again let us make the diagram for this question. This question is also from the applications of trigonometry. So the question says the shadow of a tower. The shadow will be always downwards. So the shadow of a tower is on horizontal plane. It changes from 60 to theta. Means that first it was 60 and then secondly it was theta. and this is the shadow. AB is the tower and the shadow is this particular line which I have drawn here. So shadow changes from 60 to theta, means first it was 60 degree and then it was theta. Now let us see in triangle ABC. We know the value of tan theta. Theta is 60 degree here. So tan 60 will be is equals to AB upon BC. We know that tan theta is equals to perpendicular upon base. Therefore, it will be AB upon BC. Now tan 60 degree is equals to root 3. And the value of AB is root 3x upon BC. It is given in the question that height of the tower is root 3x meter, means AB is equals to root 3x. Now from here we can get the value of BC, which is x. So we have got the value of BC, which is x. Now other triangle is triangle ABD. So in triangle ABD, tan theta will be is equals to h upon b, means root 3x upon x plus x. See, in triangle ABD, the base is BD. Since we know the value of BC, then this part also will be x. Therefore, BD is equals to x plus x. And the perpendicular or the height is same, which is root 3x. So further solving it, we get tan theta is equals to root 3 x upon 2x. So x and x will be cancelled. So tan theta will be root 3 by 2. Now we know that root 3 by 2 is greater than root 3 by 3. We can say that root 3 by 2 is greater than root 3 by 3. And when we rationalize root 3 by 3, then we will get 1 upon root 3. We know the value of 1 upon root 3. So in the place of root 3 by 3, I can write 1 upon root 3. And I can say that root 3 by 2 lies between 1 upon root 3 and 1. Since we know that root 3 by 2 will be greater than root 3 by 3. And when we rationalize root 3 by 3, we get 1 by root 3. So in place of root 3 by 3, I have written 1 by root 3 here. And we know that 1 by root 3 will be less than root 3 by 2. And root 3 by 2 will be less than 1, which I have written in the step. Now I know that 1 by root 3 is tan theta. So I can write here tan theta. And 1 is tan 45. So I can say that root 3 by 2 lies between tan theta and tan 45. Now there is one more basic thing which is remaining here. Can you tell me what is tan theta here? Tan theta will be tan 30 degree, because tan 30 is equals to 1 upon root 3. Okay, so I can say that the theta is 30 and root 3 by 2 is our value, and here again the theta is 45. So I can say that theta lies between 30 and 45. So this is the correct answer for this question. I hope you have understood this question. It seems a little bit tricky, but if you are very well with formulas and values, then you can easily solve it. You just have to first form the diagram and then one by one take a triangle and find the value of tan theta, and then write that the value lies between which angles. Next question is, if tan inverse 1 by 2 plus tan inverse x by 3 is equals to pi by 4, where x lies between 0 and 6, then what is x equal to? The question is given tan inverse 1 by 2 plus tan inverse x by 3 is equals to pi by 4. Now we can use a formula tan inverse a plus tan inverse b, which is equals to tan inverse a plus b upon 1 minus ab. It is equals to pi by 4. Now tan inverse will go to the right side, so it will become 1 by 2 plus x by 3 upon 1 minus 1 by 2 into x by 3 is equals to 10 pi by 4. This tan inverse has come to the right hand side. We know that 10 pi by 4 is equals to 1. So this term will be equals to 1. We know the value of 10 pi by 4. It is 1. So I can write 1 by 2 plus x by 3 upon 1 minus 1 by 2 into x by 3 is equals to 1. Now further solving this, we get the term which is in the denominator will go to the right hand side. So the next step will be 1 by 2 plus x by 3 is equals to 1 minus 1 by 2 into x by 3. Further solving it by taking the LCM, we get 3 plus 2x upon 6 is equals to 6 minus x upon 6. 6 and 6 will be cancelled. 2x plus x is equals to 6 minus 3. 3x is equals to 3. Therefore, the value of x will be 1. Moving on to the next question. If 3 sin inverse x plus cos inverse x is equals to pi, then what is x equal to? We know a formula which is sin inverse x plus cos inverse x is equals to pi by 2. And from here I can get the value of 2 cos inverse x. I can get the value of cos inverse x, which is equals to pi by 2 minus sin inverse x. Is it clear? So now in the question we have to replace the value of cos inverse x. So the question is 3 sin inverse x plus cos inverse x is equals to pi. Now we got the value of cos inverse x. So replacing it, we get 3 sin inverse x plus pi by 2 minus sin inverse x is equals to pi. 3 sin inverse x minus sin inverse x will be 2 sin inverse x, and right hand side will be pi minus pi by 2. Is it clear? We are just solving after putting the value of cos inverse x. Now 2 sin inverse x will be equals to pi by 2. Pi minus pi by 2 is pi by 2. Sin inverse x will be is equals to pi by 4. Now if sin inverse will go to the right hand side, x will be sin pi by 4. And we know the value of sin pi by 4. Sin pi by 4 is 1 upon root 2. So the value of x is 1 upon root 2. You can see that these questions are very simple. You just have to focus on the right part. Next question is, if tan alpha plus tan beta is equals to 1 minus tan alpha tan beta, where tan alpha into tan beta is not equals to 1, then which of the following is one of the values of alpha plus beta? It is a very simple question. Question is given that tan alpha plus tan beta is equals to 1 minus tan alpha into tan beta. Can you see that this step can form a formula which will be tan alpha plus tan beta upon 1 minus tan alpha tan beta. It is the formula for tan alpha plus beta, and here there will be 1. So I am just keeping the formula here, 10a plus b upon 1 minus 10a 10b is equals to 10 a plus b. A is alpha and b is beta. So I can say that 10 alpha plus beta is equals to 1. I hope you understood this step. We know the formula of 10a plus b. Formula is 10a plus 10b upon 1 minus 10a 10b. So further solving it, we get 10 alpha plus beta is equals to, we know that 10 pi by 4 is equals to 1. So I can write 1 as 10 pi by 4. Now 10 and 10 will be removed. So alpha plus beta is equals to pi by 4. So we have to find the value of alpha plus beta, which we have got here. See, this was very simple question. Next question is, if 1 plus 10 theta into 1 plus 10 9 theta is equals to 2, then what is the value of 10 10 theta? See, in the question itself it is given 1 10 theta and 9 10 theta, and we know that 9 theta plus theta is equals to 10 theta. So in this question we have to do something that a formula will contain 10 theta. So let us solve this question. 1 plus 10 theta into 1 plus 10 9 theta. Now multiplying it, we get 1 plus 10 9 theta plus 10 theta plus 10 theta into 10 9 theta is equals to 2. Here there was is equals to 2 in the question. We have just simply multiplied the both brackets. Now further solving it, we get 10 theta plus 10 9 theta is equals to 1 minus 10 theta 10 9 theta. Again 10 theta plus 10 9 theta upon 1 minus 10 theta 10 9 theta is equals to 1. It is the same step that we have done in the previous question. We can see that formula will be formed. So we will take this term in the denominator. Now we have the formula of 10a plus b. Can you tell me what is the formula of 10a plus b? 10a plus b is equals to 10a plus 10b upon 1 minus 10a 10b. So we will just apply the formula here. A is theta and b is 9 theta. So 10 theta plus 9 theta is equals to 1. So you know that 10 theta plus 9 theta is 10 theta. So we have got the value of 10 theta is equals to 1. I told you in the starting that we have to do something in this question, that when we apply the formula, then we will get theta plus 9 theta. So this is it. So the correct answer is 1. Next question is, what is the value of sine 0 plus sine 10 plus sine 20 plus sine 30 plus so on sine 360? While looking at this question, we think that we have to add so many values. But no, there is a very simple trick to this question. Let us see it. Sine 0 plus sine 10 plus sine 20 plus sine 30 plus somewhere there will be sine 180 between this, and somewhere there will be sine 190, and somewhere there will be sine 350, and at last there will be sine 360. And also you can write one or two values if you want. We can write here sine 170 plus it goes on. See, the values are between 0 and 360. So between 0 and 360 other values will also come. So I have written some of the values. Now firstly we know that sine 0, sine 180 and sine 360 will be equals to 0. So let us focus on the other parts. We know a very simple formula, which is sine theta is equals to sine 180 minus theta. We can also write it as sine theta is equals to minus of sine 180 plus theta. Both are equal. So this will be equals to what? Sine theta plus sine 180 plus theta is equals to 0. Means when we add both this value, the answer will be 0. So first we have sine 0 and sine 180. So keeping the value of theta here, sine 0 plus sine 180 plus 0, it will be equals to 0. So this both the terms will be equal to 0. Similarly, let us see the other parts. Sine 10 plus sine 180 plus 10 will be equals to 0. Means sine 10 plus sine 190 will be equals to 0. So again sine 10 plus sine 190 is equals to 0. Similarly, sine 20 plus sine 200 will be equals to 0. And at last, let us say sine 170 plus sine 350 will also be equals to 0. So like this, every term will be cancelled by using this formula. So since every term is cancelled, then the answer will be 0 because there is nothing remaining. I hope you have understood this question. The main part in this question was this formula. Sine theta is equals to sine 180 minus theta. You have to remember this formula in order to solve this type of questions. There was nothing in this question. You just have to know a simple formula and you can solve it. Because by using this formula, we find that sine 0 plus sine 180 is 0. Sine 10 plus sine 190 is 0. Sine 20 plus sine 200 is 0. So like this, two terms will be cancelled up to 360. So the answer will be equal to 0. Next question is, consider all the subsets of the set A, which is 1, 2, 3, 4. How many of them are supersets of set 4? Now, A is equals to 1, 2, 3, 4. Can you tell me that this question is from which topic? Yes, it is a very simple topic. This question is from the sets. So we know that its subset will be 2 to the power 4, which is 16. So the total number of subsets are 16. But we have to find the subsets which have 4 or which contain 4. So now we are taking about the sets in which elements 4 will be there. So 1 will be 4 itself. 1 is 1 and 4. Then 2 and 4. Then 3 and 4. Then 1, 2, 4. Then 1, 3, 4. Then 2, 3, 4. And then at last 1, 2, 3, 4. So you can see that how many subsets we have. Just counted 1, 2, 3, 4, 5, 6, 7, 8. So the total number of subsets which contain 4 is 8. Have you understood this? The total subsets are 16, but in the question it is said that find only those which contain 4. So from 16 there are 8 elements which contain 4, which I have written here. Next question is, consider the following statements in respect of two non-empty sets A and B, and two statements are given. This question is a very important question, so understand it very carefully. It comes many a times in exams and it is very, very important. So the first statement is X does not belongs to A union B. It is given. If it does not belongs to A in union B, means it will belong to opposite of it, which is A union B complement. Is it clear? if any element does not belongs to the union, then it will belongs to A union B complement. So we know that A union B complement is equals to A complement intersection B complement by using De Morgan's law. So we can write X belongs to A complement intersection B complement by De Morgan's. It means that X will belongs to A intersection and X will belongs to B intersection. And now, since we know that X belongs to A complement and B complement, means X will not belong to A, also X will not belong to B because it already belongs in complement. So it will not be in B. So it will not be in both of this. And option 1 is that X does not belong to A or X does not belongs to B. So this or part is wrong. So statement 1 is wrong because now we have found that X will not belongs to A and X will not belongs to B. So it does not belongs to both of them. Therefore this is correct. Now let us look at option number 2. So option number 2 is X does not belongs to A intersection B. We have to use the same steps for second part also. It is given that X does not belongs to A intersection B. It means that we can write that X belongs to A union B. And A union B will be equals to A intersection B complement. Again by De Morgan's law I can write that X belongs to A complement union B complement by De Morgan's law. Is it clear? The second statement was X does not belongs to A intersection B. So it is obvious that it will belongs to A intersection B complement. And if there is A intersection B complement, then we can write X belongs to A complement union B complement by De Morgan's law because we know the value of A intersection B complement is A complement union B complement using the De Morgan's law. Now it means that X will belongs to A complement or X will belongs to B complement since there is union and for union we use or. So it means that X will not belongs to A or X will not belongs to B. Since it is already in A complement and B complement, so X will not be in A or B. So you can see the second statement. In second statement there is AND. But we have found that it will be OR. So both the statements are wrong. It means that the correct option is neither 1 nor 2. Both the statements are wrong for this question. So I hope you have understood all this question and revised all the formulas very well. Keep learning and keep scoring high.